Hey, PreCalc. It is the 7th, which is what? Tuesday. Come back to me. I want to show you how to graph another polar equation. We went through it last night. Let's see if we can go through this one quickly. And I think they'll be hitting your assignments, your daily work tomorrow. So here is the equation. R equals 3 plus 6 sine of theta. So it's helpful to have the unit circle in front of you, and I will pick out some angles to plug in here and then come out with R. So I usually just start around the unit circle, start at 0. When I put in a 0 here, I get sine of 0, which is 0. 6 times 0 is 0, so I end up with, when I put in 0 for theta, the Death Star symbol, and we get the Death symbol, we get 3. I learned that tau is the symbol of resurrection and theta for death. I looked it up. So thanks a lot, Maddie, for messing with my head. Okay, so anyway, pi over 6, going around the unit circle, at least by 6. Pi over 6, we get the sine of pi over 6 is the second coordinate, so it is 1/2. So 6 times 1/2 is 3. 3 plus 3 is 6. This time, I can't remember what I did yesterday. I'm going to graph this, and I'm going to make these circles kind of small, because there's going to be a lot more than yesterday. So remember, this is our values away from the origin. So I'm like at 4, and my circles get worse and worse as I get bigger and bigger. Okay, more and more lopsided. So I have 6. I'm not sure if I need more than that. I think I actually do. 1, 2, 3, 4, 5, 6, 7. Sometimes if I do half at a time, it looks a little better. I'm going to put one more on. So I've got 8 steps from the origin. Alright, so at 0 degrees, which is right here, I'm going to go out a radius of 3, or an R of 3. And at pi over 6, which is here, there's pi over 3. I'm going to go out 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Alright, so I have to draw a line that goes from 0 degrees to pi over 6, from 3 to 6. So I'm going to start here and go like that. So we have to come. It's not a straight line, it's always curved. Notice it stayed in between the 0 and pi over 6 area. And it went from the value 3 to 6, like that. Alright, pi over 3 I'll do next. And pi over 3 is just going to be graphed along this angle. Sine of pi over 3 is square root of 3 over 2 times 6 is, let's see, square root of 3 over 2 times 6 is 3 square roots of 3. So then I have this plus 3. So I kind of worked here on the side. So it's going to be 3 plus 3 square roots of 3. So I did that earlier and it came out to about 8.2. So you can verify that my thetas do give the r's that I'm coming up with. So I'm going to go out at pi over 3, 8 and a little more. 1, 2, 3, 4, 5, 6, 7, 8 and a little more. There's my 8.2. So I'm going to draw a line from there to there. So this is usually a smooth curve like that. So let's keep going. I'm going to do pi over 2. So plugging that in here, I have sine of pi over 2, which is 1, 6, 3. I get 9. I don't think I drew that many circles. All right, so pi over 2 is right here. So if this was 8, I'm just going to improvise, and the ninth one would be right there. So I'm going to keep drawing my line. All right, so that's so far we have that. 2 pi over 3 is going to come up next, and 2 pi over 3, when I put it in here, the sine of 2 pi over 3, so along this line, is square root of 3 over 2, and I just am working on my little scrap area here. So I have 3 plus 6 times square root of 3 over 2, which turns out to be 3 plus 3 square roots of 3 over 2, which is my 8.2 again. So at this angle, I'm back to here. So that was 8 and a little more. Keep drawing. And I'm going to put in the other values rather quickly. You can check them out for me. 5 pi over 6 ends up to be 6. Right there. Pi turns out to be 3. So here's my pi radians. Right there. And pretty soon, 7 pi over 6, as we go around and around the circle, 7 pi over 6 would be this angle, and it turns out to be 0. So I've got to bend from where I am to 0, staying within the angle marks there. And now I'll start my curve here, my chart here, where you can see this angle is 4 pi over 3. And that ends up to be a negative 2.2. So how do I graph a negative value along this angle? If this is 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, where would negative 2 be? And it turns out to graph a negative value, you take the angle that you are examining and you go backwards through the origin at the same angle, that value. So let me show you how to do negative 2.2. All right, here's 4 pi over 3. So, but it's going to be negative, so I'm going to go back through at this angle, which really puts me at pi over 3 again. But we call it negative, and we go back 1, 2, and 0.2. So now I go from here to here. And 4 pi over 3, 3 pi over 2. 3 pi over 2 will yield negative 3. So see if you can figure out where that's going to be. Here's 3 pi over 2. So where will I graph a negative 3? Turns out that I reflect back behind the 3 pi over 2, actually on the pi over 2 line, and it's called negative 1, 2, 3. All right. And 5 pi over 3, which will be this one. Put down here on my chart. 5 pi over 3. When I plug it in that original problem, I'm going to get a negative 2.2. Some numbers keep coming up. So here's the angle. I'm going to reflect back 2.2. 1, 2, and a little bit. And when I put in 11 pi over 6, I get 0. So 11 pi over 6 is right there. I get 0, so I'll connect there. And if I go back to 2 pi, it's the same as 0, and I'll get 3 again. So I got to get from here to 3. All right. So you can see we have a shape that looks like this. It has an inner loop and an outer loop, like that. So that's called a limicon. And the C has that funny little mark on it. So somebody find out what that's about. All right, so you will be doing similar graphs. Some of your graphs will look like this. Some will look like hearts, sort of with rounded. They won't have a sharp point. It'd be like that. Some will look like this. Some will look like this. All kinds of different curves. All right, so I just wanted to show you one more, and it was for r equals 3 plus 6 sine theta, and it is a limicon with an inner loop. So how cool is that? All right, good night. Have a good one. See you in the morning.